How far will humanity go in the cosmos? Will we one day command the power of entire stars, build civilizations that span galaxies, and push beyond the limits of the universe itself? Or will we remain forever bound to our tiny corner of space, struggling to take the first step? The Kardashev Scale isn't just science fiction, it's the blueprint for our future. But how far can we truly ascend? And will we even survive long enough to find out?
Welcome to Cosmic Cat on YouTube.
In 1964, Soviet astrophysicist Nikolai Kardashev proposed a method to classify civilizations by their ability to harvest energy. Kardashev theorized that as civilizations advance, their energy consumption grows exponentially, allowing them to progress through three key stages, from a Type 1 civilization to a Type 3 civilization. A Type 1 civilization, also called planetary civilization, is capable of harnessing 100% of its planet's available energy. That means no more reliance on fossil fuels. Instead, we'd master fusion power, build vast solar farms, and perhaps even tap into the raw energy of our planet's core. Imagine weather control, unlimited clean energy, and cities powered by the very forces of nature. Right now, humanity, we're about 0.73 on the scale. Not even a full Type 1 yet. At our current pace, experts estimate we could reach Type 1 within 100 to 200 years, assuming we don't collapse due to climate change, nuclear war, or other existential threats. So, what will it take for humanity to finally become a Type 1 civilization? There are three major breakthroughs we need to achieve. 1. Mastering renewable energy. We must transition from fossil fuels to clean, limitless energy sources: solar, fusion, wind, and geothermal. If successfully harnessed, nuclear fusion could provide limitless, clean, and safe energy. So far, nuclear fusion experiments require more energy to sustain the reaction than they produce. Recent breakthroughs, like the 2022 National Ignition Facility's ignition event, have achieved net energy gain for brief moments. But turning this into a continuous power source is still a major hurdle. Secondly, global political and economic stability. Advanced civilizations require global cooperation. This means preventing nuclear war, managing resources responsibly, and developing systems that ensure technological progress without self-destruction. Without stability, we may never reach Type 1. And finally, 3. Technological revolution. The rise of AI, quantum computers, and nanotechnology will be crucial in accelerating our growth. Groundbreaking scientific advancements in battery technology and smart grids will be essential for efficiently utilizing energy on a global scale. But as we consume more energy, we must be mindful. Too much energy production on Earth could alter the climate. We are already seeing the effects of climate change today, and it would be incredibly sad if we destroyed our planet before we ever got to leave it. That means to progress beyond Type 1 to a Type 2 civilization, we will eventually need to start collecting energy in space, far from our biosphere. A Type 2 civilization, or stellar civilization, goes beyond planets. It controls the entire energy output of its star. It does so by building a Dyson Sphere, a massive structure surrounding a star to absorb 100% of its energy. A Type 2 civilization harvests 10 billion times more energy than its predecessor. With that much energy, we could colonize the entire solar system, terraform Mars, and even send spaceships to explore other systems. With interstellar travel, artificial planets, and virtually limitless resources, nothing is impossible. A Type 2 civilization is virtually immune to extinction. Scientists predict that if humanity successfully reaches Type 1, we could become a Type 2 civilization in 1,000 to 2,000 years, provided we continue advancing technologically and avoid catastrophe. Reaching Type 2 requires an entirely new level of technological mastery. Here are the key advancements needed to get there. Number 1. Building a Dyson Sphere. This is the single most important step. A Dyson Sphere, or a Dyson Swarm, a collection of energy-absorbing satellites, will allow us to capture and utilize the full power of the sun. engineering such a megastructure will require unimaginable amounts of resources and AI-managed automation. 2. Advanced space mining and megascale engineering. To construct a Dyson Sphere, we must first mine asteroids, moons, and possibly even dismantle planets for raw materials. This means perfecting asteroid mining, self-replicating robotic construction, and near-limitless industrial automation. 3. Interplanetary infrastructure and space habitats. Before we can efficiently use the energy of a star, we must colonize and terraform planets and moons. Space elevators, orbital shipyards, and fully functional off-world civilizations will be necessary. 4. Breakthroughs in energy storage and transmission. Harnessing the sun's power is one thing. Transmitting and storing it is another. We'll need revolutionary energy storage systems, like antimatter batteries or quantum energy fields, to distribute this energy across vast distances. Once we gain the ability to build a Dyson Sphere, we won't just be unlocking limitless energy, we'll be laying the groundwork for an intelligence explosion beyond anything we've ever known. A Dyson Sphere isn't just a power source, it's the foundation for a Matrioshka brain, a megastructure that could transform our very existence. A Matrioshka brain is a hypothetical megastructure that functions as an ultra-advanced supercomputer, capable of computational feats far beyond anything imaginable today. It could run highly advanced AI. A Matrioshka brain could host an AI of unimaginable intelligence, potentially surpassing biological life. It could simulate entire universes, create detailed simulations of alternate realities, or even perfect creations of past events, effectively acting as a virtual universe generator. It could host uploaded consciousness. Humans or post-human entities could upload their minds into this vast computational network, effectively achieving digital immortality. Moreover, it could solve the most complex scientific problems, from cracking the mysteries of quantum mechanics to predicting cosmic scale events. A Matryoshka brain would process data on a galactic level. This could allow us to control energy and matter at an unprecedented scale, giving us the ability to manipulate fundamental physics, potentially unlocking new forms of energy or engineering entirely new forms of existence. A Type 3 civilization, also known as a galactic civilization, is able to capture all the energy emitted by its galaxy. The Milky Way is estimated to have 100 to 400 billion stars. Imagine every single one of them surrounded by Dyson Spheres, or turned into Matryoshka brains. At this stage, life transcends biology, AI, consciousness transfer, and godlike engineering capabilities become the norm. But the question is, would a Type 3 civilization even be recognizable to us? Or would they be something entirely beyond comprehension? If humanity survives long enough, experts suggest it could take anywhere from 100,000 to 1,000,000 years to reach Type 3. Right now, we're just getting started, but every technological breakthrough, every new discovery brings us closer to climbing the scale. One day, humanity may not just rule a planet or a star, but the galaxy itself. The Kardashev Scale isn't just about sci-fi dreams, it's about our potential. If you found this journey through the Kardashev Scale fascinating, please hit like, subscribe, and let me know in the comments. Do you think humanity will ever reach Type 3 and beyond? Or will we remain forever trapped, never escaping the limits of our own solar system?